Alright, so in this video, we're going to talk about how to find the order of rotational symmetry for different shapes. So let's say we're asked to find the order of asymmetry of this square. Okay, let's start with quadrilaterals. So what is the order of rotational asymmetry of this square? So it just means that how many times are we going to rotate this square such that it looks exactly or the same in one complete rotation. So how many times is it going to look exactly the same as it is right now? So we're going to start like this. Okay, so I'm going to put a point here. So let this be point A. Then we're going to go clockwise. All right. So we're going to start with point A now, and then we're going to rotate in a clockwise motion. Okay. Let's rotate from here until when it fits exactly like before. And now it fits. So point A has moved from here to around here. Okay, so this is number one. So let's move on again. So we rotate until it fits or looks exactly the same like the square. Again, we're here. So we rotate it like this. And now our point A is here. So how many times have we rotated it that it looks exactly the same? Twice. So this is the second time. Okay. Then we rotate again. Okay. Okay. All right. So this time it looks exactly the same like before. So point A. So let me just be specific. Point A is around here. Like that's what I'm talking about. So now we're here. Okay, 3. Then we decide to rotate again to complete the rotation. And we rotate this until we get back to here. Now we're back at this point. So how many times? So point A is back here again. So how many times? Okay. How many times did the square look exactly the same? Or did it fit into the actual shape? 4 times. Okay, 1, 2, 3, and 4. So we had that 4 times. So it means that the order of rotational symmetry for a square is going to be 4 because okay, the number of times it looked exactly the same as the original as we rotated it was 4 times. So then what's going to be the angle of rotational symmetry? So the angle is like the degree of rotation after which it appears the same. Okay, so let me explain. Let me start from here. All right. So when we went from here to here, okay, when we rotated from here to here, what was the angle? Okay, the degree of rotation of a shape after which it appears the same. Okay, so what I'm going to put is I'm going to put an arrow here. Okay, extend this line like this so you can see it's facing. You can see it's facing upwards. And then if we rotate this square, okay, rotate this square. Rotate the square like this. So the arrow direction is going to change because you've rotated it and to be something like this now. It's going to be in this direction. Okay, so we've rotated the square. Okay, from this direction now to this direction. And what's the angle here? So this is actually a right angle. So we can say 90 degrees. Okay, but the same thing, if we decide to rotate the square again, okay, if we decide to rotate the square again, take it from this direction here. So now this part is going to face downwards like this. It's going to be facing down. like this. Okay, so and what's the angle of rotation? It's going to be 90 degrees because it's a right angle. So it means that the angle of rotational symmetry, it means that you have to rotate the square by 90 degrees so that it looks exactly the same as it was before. Okay, if you rotate it by just, let's say, 45 degrees, it's going to look like this, something like this. But if you do a full 90 degrees, it's going to look like this. So the angle of rotational symmetry for a square is going to be 90 degrees. Let's try for a rhombus. So a rhombus, it's like a square in the sense that all the sides are equal, but the angles, this angle is equal to this angle, and this angle is equal to this angle here. Okay, but not all the angles are the same. Okay, all right. So now for the rhombus, how do we get the order of rotational symmetry? So we can start again. Let's say this is point A, and decide to rotate this. So I decide to rotate this. Okay, so we start from here. Rotate, rotate. Wait. Let me copy another rhombus on it so that it looks you can see it clearly. I'm just gonna put another on it so you can see. Okay, so let's rotate again so that it fits well. So we start from here, we rotate, rotate, rotate. Does it look exactly the same? No, 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 no. We're rotating, we're still rotating. Yes. Now at this point, it looks exactly the same. Now, point A is now around here. Okay, so it means we went from here to here. So this is one. Also this is the first time it looks exactly the same. Right, so let's continue. We rotate, 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 rotate. Okay, rotate, rotate, rotate until we're back here again. Now, point A is back here. Okay, so we went from here to here and went back to here. So this is the second time it looks exactly the same. So it means that the order of rotation for a rhombus is going to be 2. You might ask, so for a square it was 4. Why is it 2 for a rhombus? Because in as much as all the sides are equal in a rhombus, not all the angles just are equal. Just 2 angles are equal. Okay, this one and this one, this one and this one. So the order of rotation for a rhombus is 2. Okay, what's going to be the angle of rotational symmetry? So I'm just going to remove the A's. I'm going to use my arrows again. There's actually a formula for that, but I'll talk about it very soon. So again, I extend this line here. So let's say I extend this line here. Okay, and when we rotated, extend this line here. When we rotated, we went like this, like this, like this until we got around here. Okay, so at this point now, this arrow will be facing in this direction, facing this direction. Sorry, let me facing this direction, more or less. Okay, so as you can see, we went from facing in this direction to facing this direction. So this is actually going to be like a 180 degrees, okay, because these lines are parallel in a rhombus, okay. So it's going to be, if you join these two lines together, it's going to just be like a straight line. You just made a 180 degree turn or 180 degree rotation. So the angle of rotational symmetry for a rhombus would be 180 degrees. You can also use the formula, which is 360 over order of rotational symmetry. Okay, so what's the order of rotational symmetry for a rhombus? Our answer is 2. So we do 360 over 2, which is 180, and we get our answer. So this way is just, I just did it like the visual way, but then you can also, use the calculation, the formula. Okay, so let's go to a rectangle again. Order of rotation for a rectangle. So again, let's start from this point. We decide to rotate this. Let's rotate this. Okay, so rotate. I'm rotating. Okay, we're 90 degrees now, but it still doesn't look the same. We're going. You can follow the point until it's somewhere around here. So at point A, yeah, now it fits exactly. So that point A will be somewhere around here. So this is the first time it looks exactly the same. So let's continue. Follow the point. Follow that corner. You can see it's moving until we get back here. Sorry. Until we get back here. So this is the second time it looks exactly the same. So we're done. We rotated it. We completed the rotation and it looked exactly the same twice. So our order of rotation here is going to be 2. Okay. And then if the order of rotation of a rectangle is 2, what is the angle of rotational symmetry? Order of rotational symmetry, angle of rotational symmetry. That's going to be 360 divided by, what's our order? 2, which is 180. So it means that you have to rotate this rectangle by 180 degrees, to get the exact shape. Okay, if you rotate this rectangle by just 90 degrees, see what happens. So if you rotate this by just 90 degrees, it's just going to be like this. So it doesn't fit. But if you do a full 180, yeah, then it comes back here. So it looks exactly the same. All right, so that's just it for irregular quadrilateral. I mean, there are more quadrilaterals like the diamonds, the kite, and all. All right, but for other quadrilaterals, for something like an irregular quadrilateral, like the let's say the trapezium or any other irregular quadrilateral, the order of rotation is going to be 1 because it's only like since all the sides are not the same, like the sides are irregular, are not the same size. So no matter how you rotate this, let's try to rotate this one. We rotate doesn't look the same. So let me just put a point here. So point A. So starting from here, point A, we rotate. No, 90 degrees. No, try again. No, doesn't fit at all until we come back to the original distance. So we have to go once. Okay, it only looked exactly the same once, and that was when we completed the rotation. So for irregular, what do you call it? For irregular shapes, okay, their order of rotation is always going to be 1. And if the order of rotation is going to be 1, it means that the angle of rotational symmetry, the angle is always going to be 360. So you have to do a complete 360 degrees move so it can look exactly the same. So this is for other irregular shapes. For a parallelogram, just like the rhombus, okay, it's going to be 2. Okay, and you see, yeah, I think that's just it. So I'm just gonna make a table. Okay, so I just also wrote this. Now for regular polygons like the square, okay. So things like the square or let's say a regular pentagon, where, okay, or regular hexagon. Sorry about my drawing. Yes, yeah. So regular polygons where all the sides are equal, just like a square, and all the angles are equal. Okay, just like a square, all the angles are equal, sides are equal. Then the order of rotation is equal to the number of sides. So just like the square, the order of rotation was 4, the number of sides is 4. So a pentagon, okay, a regular pentagon where all the sides are equal and all the angles are equal, then the order of rotation is going to be a 5. For a hexagon where all the, let me try and draw this hexagon again, not sure why it's, okay, now it looks good. Okay, so where hexagon where all the sides are equal and all the angles are equal, then the order of rotation is going to be 6. Okay, and also an equilateral triangle. Okay, so for all these where the angles, all the sides are equal and all the angles are equal, regular polygons, then the order of rotation is equal, is automatically equal to so even a pentagon, etc. Okay, and then remember for polygons, irregular polygons, the order of rotation is always equal to 1, and then angle of rotational symmetry actually, but just or the angle of rotational symmetry be 360 divided by 1, which is equal to 360. Okay, yeah. And then for special cases like a circle, now where is that circle? I had a circle somewhere. Okay, let me see if I can draw a perfect circle. Might not be perfect, but okay. This doesn't look exactly like how so, but okay. I think this is fine. Okay, let's have to copy. Let me copy this. So let me impose the circle on this circle, and let's try to rotate the circle. So this is not a complete circle. It's not a perfect circle. But no, this is not. Yeah, it's not a perfect circle. So I think I know what I'm going to do. I'm going to look for a perfect circle online, and okay, I'm just going to copy this image. Okay, so we have this circle here. I will just draw on it so it fits exactly. Okay, now this one fits. Yeah, this one is better. Okay. Move this one. Copy this. Impose it. Again, if we try, let's try to rotate it. So what are we gonna get? It's kind of not perfect, but the idea is that for a circle has an infinite order of infinite order of rotational symmetry. So it's like no matter how you rotate the circle, it's always going to fit in. Okay, so no matter how you rotate the circle, it's always going to fit, fit in because all sides are. It's just a circle. It can continues. So let me see if I can get this circle well. And I can see where the mistakes were. I think this is a better circle. This is more like an oval. I think this is a good circle. Okay, so again, when I try to rotate it, you can, it's okay. Well, but the idea is that it just keeps on being a circle. It doesn't really, it's just inside. It's just, yeah, it's not perfect, like, because maybe I didn't draw the circle well, but, it's just, it just continues. No matter how you rotate it, it still fits in the circle. Okay, you can see it still fits. Rotate this way. It's there. All right, so I think that's just the idea. So I'm gonna put everything here. So that's the order of rotational symmetry and the angle of rotational symmetry. Okay, for regular polygons, that's easy to get. Order of rotation or rotational symmetry is equal to the number of sides, and then for irregular polygons, the order of rotation is going to be 1. Then for special ones like the rectangles, parallelograms, those are 2. All right, so I hope this helps, and have a wonderful day.